What am I doing wrong? Okay, let's take a look. Here, we have a limit of a multivariable function, and we have x, y approaching 0, 0. So if we plug in 0 and 0 into x and y, we get 0 over 0, so we have to do more work in order to figure out the answer. Now, let me go over what you did. You use the polar coordinates, and the good thing is that because x, y is approaching 0, 0, so r is approaching 0. And we just have to worry about r right here. So it's a great idea. Use polar coordinates, plugging this into all this, we get this expression. On the top, we can factor out the r to the third power. On the bottom, we can factor r to the first power. And then we can reduce out one of the r's. So we have r squared times cosine cube theta plus sine cube theta over r times cosine squared theta plus sine theta. Now this right here should look pretty good because we can just plug in 0 into r and we will have 0 times this quantity over plugging 0 into this r, which is just going to be 0 times this, and then plus sine theta. On the top we have 0, on the bottom we have sine theta, which will just end up with 0, right? Unfortunately, this right here is actually not the correct answer for this limit. Why though? Here's the technical part. Remember right here we have r is approaching 0, but we still have another variable in the polar coordinate system, the theta. Theta can be anything. So if you look at this right here, we have sine theta. What if theta happens to be 0? Sine theta, when theta is equal to 0, that will also give us 0. So we'll end up with 0 on the top over 0 on the bottom. So again, we cannot draw any conclusion once we have this situation. I cannot say the answer doesn't exist. I cannot say the answer is equal to 0. Nothing. Unfortunately, this method just doesn't work when we have sine theta on the bottom like this because of this situation. So what do we do though? Well, don't worry, let me show you. Here's the deal. Whenever we're trying to evaluate the limit of a multivariable function, especially when we have x, y approaching the origin, the polar coordinate is a great idea, but it didn't work. So let's try another method. We could also guess an answer for the limit and then try to prove it. But to prove a limit, we will have to use the epsilon delta definition. It's not easy, and especially if we guess the limit incorrectly, then of course the steps are not going to work out nicely. So that's quite hard. And of course, if you look at this expression, we cannot factor anything, cancel anything, not that either. Before we continue though, make sure you check out my video because I showed you guys several methods on how to evaluate the limit of a multivariable function. The link will be in the description. It's usually not that easy. So why don't we try the other approach? Why don't we try to show this limit doesn't exist? Because to show a limit doesn't exist, you just have to come up with two paths and they give you different limits. And the hardest part for that is just you have to come up with the path. Let's start with an easy one first. I'm going to say we are going to go along. Because we have x, y approaching the origin, I'm just going to say x is equal to 0, so we are talking about the y-axis. So now, if we plug in 0 into the axis, we have 0 cube plus y cube over 0 square plus y. This is the expression that we have, so we just have y left, right? So we just have the limit as y approaching 0, and we are back to the one variable situation. We can cancel, so this right here is just the limit as y approaching 0 of y squared. Plugging 0 into here, the answer is just equal to 0. Done. Now, the next thing is, we will have to come with another path that does not give us the limit being equal to 0, because otherwise, I cannot draw any conclusion. So what can we do though? We used x is equal to 0, can we try y is equal to 0? I don't think so, because if we have y is equal to 0, we don't have those things, and we'll run into a similar situation, we will still end up with 0. That doesn't work. Okay, let's try another one. This is another one that maybe You should keep in mind, just try it. Let's try y is equal to a line. Let's just do the diagonal. Y is equal to x. Here's the origin. Y is equal to x is like that. We are approaching 0 on this diagonal. So what I'm going to do is, I will plug in x into the y's here. So we will have x cubed plus x cubed over x squared plus x. So this expression is all about just x. So that's the limit as x approaching 0. And let's see. That's 2x to the third power on the top. On the bottom, I can factor on x. And then perhaps I can reduce one of them out. And if I put 0 into here, we have 2 times 0 on the top over 1. 0 over 1 is just equal to 0. I cannot draw any conclusion. 0, 0. It doesn't mean the answer right here is equal to 0. No. No, no, no. So, what do we do? Again, let me show you. Here, I'm going to choose the following path. Here is a general strategy. Notice how we have y to the first power on the bottom. Let's try to pick y equal to something so that I can first get rid of the x squared. In that case, I will have to have minus x squared. But if I just have this, once I put it on the bottom is equal to 0. That's really bad, right? So let's pick something else. And this is how else you can do it. Look up right here. Notice that we have x to the third power, right? Go ahead and put plus x to the third power. This is just a good strategy. And then we will have to hope for the best. We hope once we plug in this into the y here and compute the limit, we don't get a limit that's equal to 0. If that's the case, then we can show that doesn't exist. This right here will work because I did this question already before I record the video. Anyways, here we will just have to check the limit as, okay, let's put this right here first. So we get x cubed plus parentheses negative x squared plus x cubed, and then third power over x squared plus negative x squared, and then plus x cubed. So it's all just x, right? So that's the limit as x approaching 0. On the bottom, this and that cancel. We just have x to the third power. And now, this is the reason why I want to pick x to the third power from the top. Because if I have x to the third power on the top, then I will hope the top has a factor of x to the third power, so I can factor that out and I can reduce that with this. Have a look. Here we have x to the third power. Here we have a lot of x's. It's going to work. First, I'm just going to factor out x squared from the parentheses inside. So that's plus parentheses x squared times negative 1 plus x. And then raise that to the third power. And I will just multiply this and that power. So this is equal to, here I still have x to the third power, and this will give us x to the 6th power, and then I multiply that with negative 1 plus x to the third power. Does it work? Yes. Have a look. We can factor x to the third power, and that's going to be very, very nice. Factor that out, we will have a 1 left. This one is crucial. And then we have plus x to the third power because we took 3 of them out. And this right here just stays, doesn't matter, over x to the third power. And now, ladies and gentlemen, cancel, cancel. And we are going to put 0 into the x here. Well, this is just 0 times whatever. Doesn't matter. This will just be 0. So as you can see, the limit right here is equal to 1. So this is 0. This is 1. They are not equal. Let me just put this down right here. Not equal. Therefore, we can go back to the original limit and say this limit does not exist. and then we are done.